The Great Pyramid stones fit together with a precision that defies its own era. For centuries, this impossible accuracy has baffled experts, leaving a gaping hole in our historical narrative. By the end of this journey, you will possess a new lens through which to see every ancient wonder on Earth. We are about to explore the compelling theory of the resonance phenomenon, the idea that sound and vibration were the secret tools of the ancients. How could a simple chant soften solid granite? What forgotten science links the pyramids to the mountains of Peru? This investigation will take us from echoing chambers to monolithic walls, unraveling a forgotten science that might rewrite history itself. What does it suggest about the true potential of human innovation lost to time? The physical evidence itself tells a story our textbooks struggle to narrate. Take a close look at the stone walls of Sacsayhuamán in Peru, where blocks weighing many tons are interlocked in a dizzying, three-dimensional jigsaw puzzle. The joints between these stones are so incredibly tight that, even after centuries of earthquakes, you cannot slide a single piece of paper between them. This is not rough masonry. This is precision engineering on a monumental scale, achieved with what we are told were simple tools of stone and bronze. Modern stonemasons, equipped with diamond-tipped saws and laser guides, would find this work extraordinarily challenging to replicate. The gap between the accepted timeline of human technological development and the artifacts staring back at us is not a small discrepancy. It is a chasm. Engineers who approach these sites not as archaeologists but as mechanics see this immediately. Christopher Dunn, an engineer who meticulously studied the Great Pyramid, noted that the flatness of its core stones is comparable to the tolerances found in modern optical manufacturing. The surfaces are not just roughly flat, they are precision ground. This level of workmanship implies a profound understanding of materials, of geometry, and of a process that made hard stone behave almost like a softer, more malleable substance. The lingering question becomes unavoidable. Could the ancients have possessed a fundamental principle of physics, a kind of forgotten applied science, that transformed their relationship with the very earth they built upon? This is not about aliens or lost super-civilizations in the fantastical sense. It is about re-examining the tools we assume they used and asking if the greatest tool of all was not in their hands, but in the air around them. What if the secret to moving and shaping mountains lay not in brute force, but in finding the right frequency? The classic image of an opera singer shattering a crystal glass with a sustained high note is more than a party trick. It is a visible, dramatic demonstration of a universal physical law in action, the principle of resonance. Every object in our world, from the smallest grain of sand to the largest mountain, has a natural frequency at which it prefers to vibrate. Think of it as the object's hidden signature song. When an external force, like a sound wave, matches that exact natural frequency, something remarkable happens. Energy is transferred with incredible efficiency, and the vibrations within the object begin to amplify. It is not about raw power, but about perfect timing. A gentle, perfectly timed push on a child's swing will send them soaring higher with each pass, while a series of random, forceful shoves will only make the ride jerky and unstable. Resonance works the same way. It is the art of the perfectly timed push. The pioneering inventor Nikola Tesla once framed our entire reality through this lens, stating, "If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration." This is not poetic metaphor, but a description of foundational physics. Resonance is not magic, it is a fundamental law of nature, as reliable and predictable as gravity. So this raises a profound historical question. If this law governs everything from bridges to wine glasses, And if ancient builders possessed a deep, empirical understanding of the natural world, is it not conceivable they learned to listen for the song of the stone? Could they have discovered that by finding the precise resonant frequency of a granite block, they could, with the right sustained tone, cause its internal structure to loosen, to become temporarily plastic, or to separate cleanly along unseen fault lines? The leap from observing a shattered glass to softening a monolith is vast, but the underlying principle connecting them is identical. It suggests a path to power that requires no modern machinery, only a profound understanding of a hidden world of vibration. The legends are too widespread to be mere coincidence. Across continents and centuries, from the high plateaus of Tibet to the deserts of the Middle East, ancient texts and oral traditions return to a single, impossible theme. Sound can move stone. Tibetan Buddhist histories speak of monks using trumpets and drums to levitate massive blocks up mountainsides to build monasteries. In the biblical book of Joshua, the walls of Jericho famously crumble after the Israelite priests circled the city for 7 days, culminating in a blast from their ram's horns. These are often dismissed as religious allegory or poetic exaggeration, but their consistency points towards something else entirely. They read like cultural memories passed down through generations of a technique so powerful it became woven into the fabric of myth. The medieval Arab historian Abul Hassan Ali al-Masudi recorded a particularly telling account. He wrote that during the construction of the pyramids, the builders would place a magical papyrus under the stones, causing them to become obedient and move forward of their own accord. To a modern mind, this sounds like pure fantasy, but what if we strip away the layer of symbolic language? A papyrus inscribed with symbols could be a diagram, a set of instructions, or a representation of specific sonic patterns. The obedience of the stone could describe the resonant state where a monolith, humming at its natural frequency, becomes far easier to guide or transport, almost as if it were floating. This interpretation transforms a magical story into a potential technical manual, written in the only vocabulary available at the time. Why would cultures with no known contact with each other all tell versions of the same story? It is a question that echoes. It suggests that the manipulation of matter with sound was not the invention of one brilliant civilization, but a piece of a universal ancient science, discovered and then lost, its principles surviving only in the language of legend. This leads us to the next logical step in our investigation. If these stories hold a kernel of physical truth, what kind of tool could possibly generate vibrations powerful enough to dance with mountains? The answer may lie not in complex machinery, but in the deliberate shaping of earth and stone itself. The accepted tools of the Bronze Age create a puzzle where the pieces simply do not fit. Picture the standard archaeological reconstruction, workers with copper chisels and stone hammers, hauling ropes over wooden rollers. Then look at the artifacts they are said to have produced. The dissonance is staggering. Granite and basalt, some of the hardest stones on our planet, were shaped into perfect curves, polished to a mirror finish, and fitted with microscopic precision. Copper, by comparison, is a soft metal. A modern materials scientist would tell you that attempting to quarry and dress granite with a copper chisel is like trying to carve a brick with a stick of butter. The tool would deform and blunt long before it made meaningful progress on the stone. This is not a matter of effort or time. It is a fundamental mismatch of material properties. The unfinished obelisk in Aswan, Egypt, provides a crucial snapshot. Lying in its granite quarry, this massive monument cracked and was abandoned. The tool marks on its surface are clear, showing the methods used, but they also highlight the sheer, overwhelming difficulty of the task. The workers were using stone pounders, essentially large balls of dolerite, to literally pulverize the granite bit by bit in a process that would have been deafening, exhausting, and incredibly slow. While this shows one method was possible, it makes the achievement of the finished, flawless obelisks and pyramid blocks seem even more superhuman. The logistical challenges only deepen the mystery. Transporting a single 800-ton megalith, even on a prepared causeway, represents an almost insurmountable feat of coordination and brute force. Aligning structures across miles with celestial precision, or creating those seamless, interlocking joints, speaks to a level of planning and execution that seems disconnected from the rudimentary toolkit we have assigned to these builders. There is a gap here, a wide and puzzling space between the means we attribute to the ancients and the magnificent ends they achieved. It is a mystery gap that conventional explanations strain to fill, suggesting that something is missing from our historical toolbox. This logical impasse forces a reconsideration. If the tools in the museum cases could not have done the work we see, then perhaps the real tools were not left behind in the dirt because you could not put them in a case. Perhaps the most important tool was not an object to be held, but a technique to be heard, a forgotten science that turned the very air into a precision instrument. This brings us to a principle that feels almost like a form of silent communication between objects. Picture two identical tuning forks placed on a table several feet apart. When you strike the first one, causing it to vibrate and sing out a pure, clear tone, something remarkable happens. The second tuning fork, untouched, begins to hum softly in perfect unison. This is not magic, it is sympathetic vibration, a fundamental law of acoustics. The first fork sends waves of energy pulsing through the air at its specific natural frequency. When those waves reach the second fork, whose structure is designed to resonate at that exact same frequency, it absorbs that energy and begins to vibrate in sympathy. It is a physical conversation, a transfer of energy through harmony. Now, extend this concept beyond a small metal instrument. Every substance on Earth, from a block of wood to a slab of granite, possesses its own unique natural frequency, a signature determined by its density, shape, and internal structure. This is the stone's hidden song. The revolutionary idea is this: if ancient builders could discover that song and match it with an external source of sound, they could, in theory, induce a state of powerful sympathetic vibration within the stone itself. What would that look like? At a high enough amplitude, this internal shaking could temporarily alter the material's properties. The bonds between mineral grains could loosen. Friction could dramatically decrease, making the massive block slide more easily. In an extreme application, the entire mass could enter a temporary state of plasticity, becoming malleable, almost fluid-like, allowing it to be molded or shaped with a precision that seems impossible by blunt force. This is not science fiction. We use this exact principle in cutting-edge manufacturing today. Ultrasonic cutting tools employ high-frequency vibrations to cleanly slice through brittle materials like glass, ceramics, and hardened steel. The vibrating blade does not crush the material. It transmits energy that causes the material at the point of contact to essentially come apart with minimal resistance. Another modern example is found in some advanced concrete and asphalt compactors, which use specific vibrational frequencies to settle the material more densely and uniformly than static weight ever could. The technology is different, but the underlying physics of using resonance to manipulate matter is identical. So we are left with a pivotal, reflective question. If our most advanced engineers use the science of resonance for precision work in the 21st century, is it truly so far-fetched to consider that a brilliant, observant ancient civilization, over centuries of trial and observation, could have discovered a macro-scale application of the same laws? This shifts the resonance theory from a fringe speculation into a realm of genuine physical plausibility. It provides a missing mechanism, a how that could begin to explain the what we see in the archaeological record. But a plausible mechanism is not yet proof. The true test lies in the stones themselves. If such a technology was employed, would its signature still be visible after thousands of years? Could we find, etched into the ancient monuments, the subtle fingerprints of a forgotten sonic science? The fingerprints of a forgotten science may still be echoing in the stones of Baalbek. In Lebanon's Bekaa Valley rests a foundation so colossal it seems to challenge the laws of physics, the ancient terrace of Baalbek. Here, resting upon a row of smaller blocks, lie 3 monoliths known as the Trilithon, each one a staggering 800 tons of precision-cut limestone. And nearby lies the even more mind-bending stone of the pregnant woman, an unfinished block estimated to weigh over 1,000 tons. To stand before it is to feel a profound dislocation from history. How was this quarried? How was it intended to be moved even a single inch? The sheer scale of the work makes the pyramid seem almost modest by comparison. For a long time, the conversation around Baalbek focused solely on the visual, the immense weight, and the puzzling logistics. But a new field of inquiry is changing the questions we ask. It is called acoustic archaeology, and it proposes that we stop just looking at these sites and start listening to them. Researchers investigating Baalbek have noted something curious about the foundation stones. Their immense size and the specific way they are fitted might do more than provide structural support. Some speculate they could act as a form of acoustic damping, deadening ground vibrations from earthquakes or even from ceremonial activities above. Others suggest the entire platform was engineered to amplify or channel specific frequencies. While still speculative, this shift in perspective is revolutionary. It treats the monument not as a silent sculpture, but as a potential instrument. In informal experiments, visitors and researchers have reported that striking certain stones at Baalbek with a hammer produces not a dull thud, but a clear, bell-like ring, a resonant tone that seems to hang in the air. This is not proof of ancient sonic technology, but it is a compelling clue. It demonstrates that these megaliths possess distinct acoustic signatures, a physical property that a resonance-aware culture would have certainly recognized and potentially utilized. Why choose a stone that rings like a bell to be the literal foundation of your temple? Perhaps because that tone mattered. This approach transforms Baalbek from a static puzzle into a dynamic space. It encourages us to consider that the builder's mastery extended beyond geometry and astronomy into the realm of vibrational harmony. They may have been selecting and placing stones not only for their visual grandeur or compressive strength, but for their sonic properties, crafting a foundation that was acoustically tuned. This idea that the largest stones ever cut by human hands might have been chosen for their song opens a door to a completely different understanding of ancient genius. It suggests their world was not silent but humming with intention, a world where architecture and acoustics were inseparable sciences. The sand on the vibrating plate begins to dance. Scattered randomly at first, the grains suddenly leap into motion, organizing themselves into intricate, symmetrical patterns. Stars, mandalas, and complex geometric lattices form and hold their shape, a perfect marriage of chaos and order. This is the science of Cymatics, a field pioneered by the Swiss physician Hans Jenny in the mid-20th century. Through his experiments, Jenny demonstrated something profound and beautiful, that sound has a shape. A pure, sustained frequency, when transmitted through a medium like sand or water, will force that material to arrange itself into a specific, repeatable pattern. The sound wave becomes a physical template, imprinting its hidden geometry onto matter for all to see. This is our fourth principle, the idea that sound does not just vibrate matter, it can inform it. The patterns Jenny captured in his laboratory are not random artistic expressions. They are direct physical manifestations of the mathematics of vibration. And when you look at them, a startling connection emerges. The stars, the concentric circles, the interlocking hexagons, they bear an uncanny resemblance to the sacred geometry found in ancient art and architecture across the globe. From the flower of life etched into Egyptian temples to the labyrinthine patterns on Celtic stones, these motifs appear again and again. For centuries, we have interpreted them as purely symbolic, as spiritual decoration. But what if we have been reading them only half correctly? What if these patterns were also technical? The Cymatics hypothesis proposes a revolutionary possibility. If ancient builders understood that specific sounds created specific patterns, they could have used this knowledge as a form of applied sonic engineering. Imagine needing to shape two granite blocks so they fit together with that impossible paper-thin seam. Instead of relying on a master stonemason's eye alone, what if they used a controlled, resonant frequency? The theory suggests that by inducing a powerful, specific vibration in the stone, perhaps using large singing bowls, tuned pipes, or even the human voice in chorus, they could cause the material to temporarily enter a more malleable state. At the same time, the cymatic pattern of that frequency would act as a kind of invisible guide, a vibrational blueprint. The stone, humming in sympathy, might naturally tend to conform to that energetic template, making it easier to work into the desired shape with astonishing precision. This moves the idea beyond simply making stone easier to move. It suggests a process of controlled information transfer, where sound carried the instructions for the final form. This leads to an even more intriguing question about the artifacts left behind. Could some of the intricate, seemingly decorative carvings on ancient megaliths be something else entirely? Could a spiral or a series of concentric circles be a recorded instruction, a diagram indicating the resonant frequency or waveform needed to work that particular type of stone? It would be a perfect fusion of art and science, where the symbol holds both spiritual meaning and practical technical data, a language of creation understood only by the initiates of that craft. This perspective does not diminish the spiritual significance of these symbols, it potentially deepens it. It suggests the ancients saw no separation between the physical and the metaphysical, between the vibration that shapes a stone and the vibration that shapes the soul. They may have been working with a unified science of resonance, where sacred geometry was not just a representation of cosmic order, but a practical map of its vibrational architecture. The connection between geometry and harmony is not a modern idea, it is written into the fabric of the universe itself. A simple experiment reveals the link. Pluck a taut string and it produces a fundamental tone. Divide that string in precise ratios, and you create the intervals that form the foundation of all music. The ratio of 2:1 gives us the octave, 3:2 gives us the perfect fifth. These are not arbitrary numbers, they are the mathematical relationships that our ears perceive as beautiful consonant harmony. Now step back from the musical scale and look at a blueprint. Astonishingly, these same harmonious ratios, the perfect fifth, the golden ratio, appear again and again in the sacred geometry etched into ancient temples and encoded in structures like the Great Pyramid. This is the compelling theory that these pervasive patterns were far more than symbolic art. They may have been a functional frequency map, a mathematical language describing the resonant properties of both matter and space. Acoustic researcher John Stuart Reid has spent years investigating this possibility, particularly within the chambers of ancient Egypt. His work involves studying the resonant frequencies of enclosed spaces, like the granite sarcophagus within the king's chamber of the Great Pyramid. Reid's measurements suggest the sarcophagus and the chamber itself were dimensioned to amplify specific, very low frequencies, tones that fall within the range of human hearing, but at its deepest, most visceral end. This was not an accidental result of random construction. The precision of the stonework indicates the dimensions were deliberate. So what happens in a space tuned to a specific frequency? It becomes a resonator. Just as a guitar body amplifies the vibration of its strings, the entire chamber could amplify sound waves that matched its design, filling the space with a powerful, pervasive hum. This transforms our understanding of the structure's purpose. Were these silent, austere chambers actually designed to be played, like giant musical instruments carved from stone? Consider the king's chamber itself. Its rectangular shape, its specific length, width, and height, all made from massive granite blocks, create a unique acoustic environment. Calculations and experiments suggest its fundamental resonant frequency is close to 114 Hz. This is a fascinating number, as it falls within a range that some modern studies suggest can influence brainwave patterns, potentially promoting states of focused calm or heightened awareness. This is not to make mystical claims, but to observe a profound correlation. The builders, who demonstrated a masterful understanding of astronomy and mathematics, likely also understood the physical effects of their creations. If they knew how to use resonance to shape stone, is it not logical they would also explore how shaped stone could, in turn, shape resonance? The architecture then becomes a frozen song, a permanent instrument designed to generate a specific vibrational environment. This elevates the entire discussion from mere construction technique to profound cultural purpose. The sacred geometry seen in the flower of life or the proportions of a temple are not just pictures of harmony, they are the architectural blueprints for creating it. The same ratio that makes a musical interval pleasing may have been used to lay out a temple floor plan, because that ratio would make the space itself resonate in a specific, desirable way. The structure becomes a transducer, converting ritual chant or the sound of a tuned instrument into a physical experience that filled the entire space. This points toward a holistic ancient science where music, mathematics, medicine, and spirituality were not separate disciplines, but interconnected expressions of one vibrational reality. The reflective question then becomes deeply personal. If these places were designed as resonant chambers, what was the intended effect on those who entered? Were they meant to quiet the mind, to alter perception, to facilitate a different state of consciousness for ceremony or healing? This idea suggests the ancients were not just building monuments to last, but crafting experiences to transform, using the universal language of frequency as their primary tool. Edward Leedskalnin's Coral Castle stands as a modern whisper of an ancient secret. Working alone through the night, this slight man single-handedly moved and positioned massive blocks of coral rock, some weighing many tons. He claimed to understand the secrets of the pyramids and spoke of harnessing magnetic currents. While his exact methods died with him, his work points toward a missing piece in our puzzle, a principle that might bridge the gap between resonant vibration and physical movement. This is our fifth principle, the role of water as a resonance amplifier and a transformative transport medium. Water is far more than just a liquid. It is a conductor of energy, a medium that carries vibrations with incredible efficiency. Think of how sound travels farther and clearer underwater. Now, consider the logistical nightmare that has troubled every engineer who has studied the ancients. How do you move a 1,000-ton block of stone for miles without modern machinery? The conventional image of thousands of workers hauling ropes over log rollers is not just exhausting to imagine, it presents immense practical problems. The ground pressure under such a colossal weight would cause any wooden roller to splinter and sink into the earth. The friction would be nearly insurmountable. But what if the solution was not to fight friction, but to erase it? This is where water and resonance could combine into a powerful ancient technology. The concept is called acoustic liquefaction. It is a process we can observe and even use today. If you take a container of dry, loose sand and vibrate it at a specific frequency, nothing much happens. But saturate that same sand with water and apply the right vibration, and something remarkable occurs. the water pressure between the sand grains increases, the grains lose their stable contact, and the entire mass temporarily behaves like a dense fluid. Solid ground becomes a slurry. Modern construction uses this principle to drive piles and stabilize foundations. For an ancient builder, the application is profound. Imagine preparing a pathway from a quarry to a temple site. By saturating the earth with water and then applying a specific, sustained frequency, perhaps from large drums or tuned stones, the ground could be turned into a temporary, near-frictionless slipway. A massive stone on a sledge would then glide across this liquefied surface with a fraction of the effort required to drag it over dry land. This is not magic, it is applied physics, a clever manipulation of natural forces. This idea gains traction when we look at the locations of many ancient megalithic sites. They are consistently found near abundant water sources, not just for the practical needs of a workforce, but potentially as a core component of the construction method itself. The quarries for the great stones of Baalbek, for instance, are situated in a slope where water could have been easily channeled. The pyramid builders of Egypt had the Nile. The temple makers of Cambodia had intricate canal systems. Water was not just nearby, it was integral to the landscape. Could it have been integral to the work as well? The theory suggests that by flooding a quarry floor, workers could have used resonance to both loosen the bedrock for extraction and then to create a lubricated channel for initial movement. The combination of sonic frequency and water transforms a back-breaking engineering problem into a manageable one. It turns the earth itself into a cooperative partner. The implications are staggering. It suggests the ancients viewed the elements not as obstacles but as tools in a unified system. Stone had a song, and water was the medium that carried that song, amplifying its effects. A resonant frequency could make the stone internally malleable, while the same vibration, channeled through a water-saturated pathway, could make the world around it yield. This paints a picture of a construction site vastly different from the chaotic, labor-intensive scenes we often envision. Instead, we might imagine a more orchestrated, almost ceremonial process. The air hums with a deep, pervasive tone. The ground shimmers not with heat but with vibration, and across this prepared stage, the great stones move with a strange, fluid grace. This perspective does not diminish the achievement, it elevates it. It replaces the image of mindless toil with one of profound intelligence, a deep listening to the laws of nature and a mastery in coaxing those laws to manifest their will. It solves the puzzle of transport not with mythical giants or alien help, but with a forgotten harmony between sound, stone, and water. Yet, even with a method for moving the mountains, another question arises. How did they know where to put them? The placement was never random. These resonant structures were aligned with a precision that points to the stars themselves. Moving an 800-ton block of stone is a problem that stops modern engineers in their tracks. The logistics are not just difficult, they border on the physically absurd. Take the unfinished obelisk in Aswan, Egypt. Had it been completed, it would have weighed over 1,100 tons. To transport something of that mass, conventional archaeology suggests a method of sledges and lubricated pathways pulled by thousands of workers. But when civil engineers run the numbers, the reality of that image crumbles. The friction between a wooden sledge and a stone or earthen road, even with water or mud as a lubricant, is immense. Calculations suggest it could require a pulling force equivalent to the combined effort of several thousand individuals acting in perfect unison, a coordination nightmare of epic proportions. The ropes themselves would need to be impossibly thick and strong, and any slight unevenness in the path could cause the entire apparatus to sink or snap. The timeline becomes another impossible hurdle. Moving a single such block just a few miles could take months, if not years, of continuous, perilous labor. Now multiply that by the hundreds of colossal stones in a single pyramid complex. the sheer man-hours required stretch the bounds of historical plausibility. This is not an isolated puzzle. On Easter Island, the famous Moai statues, some weighing over 80 tons, were somehow transported miles across rugged terrain from the quarry to their coastal platforms. The leading theory of walking them upright with ropes, while creative, presents its own set of extreme stability and control issues. The gap between what we believe was possible with the available technology and what was actually achieved is not a minor detail. It is the central conundrum of ancient mega-engineering. This tension becomes crystal clear in a more modern example. In the 1830s, France embarked on a project to bring the ancient Luxor obelisk from Egypt to Paris. This was not an 800-ton monster, but a relatively modest 250-ton monument. The operation was a feat of 19th-century engineering genius. A custom-built, ocean-going barge was constructed. A complex system of pulleys, winches, and inclined planes was designed. The process took years of planning and execution, involving teams of skilled engineers and laborers using iron, steam, and advanced mathematics. The successful installation in the Place de la Concorde was celebrated as a triumph of modern technology over ancient scale, and that is the telling point. It took the industrial age to move, with great effort, a single obelisk that was a fraction of the weight of the truly massive stones found at Baalbek or within the Great Pyramid. If our own ancestors just a few centuries ago needed such an elaborate, resource-intensive operation for a 250-ton stone, how can we comfortably accept that a Bronze Age society moved stones 3 or 4 times that weight repeatedly with only wood, rope, and copper? The conventional explanations do not just have gaps, they have canyons. The physical evidence of the stones and the logistical nightmare of moving them create a historical problem that demands a better solution. This is why the resonance theory transitions from an interesting speculation into a necessary line of inquiry. It is not about seeking magic, but about searching for the missing piece of physics that could turn an impossible haul into a manageable task. If vibration could temporarily reduce friction or even make the ground itself more fluid, as we explored with acoustic liquefaction, then the entire logistical equation changes. The need for thousands of straining workers is replaced by the need for a precise, sustained tone. The image shifts from brutal force to applied knowledge. This conundrum forces us to ask, did the ancients possess a fundamental understanding of energy transfer that we are only now beginning to rediscover in our most advanced laboratories? The stones moved, that much is undeniable. The question history has failed to answer satisfactorily is how. Perhaps we have been looking for the answer in the wrong form, searching for complex machinery in the dirt, when the real machinery was invisible, humming in the air and resonating through the earth itself. The rhythmic pulse of a work song is more than just a way to pass the time. It is a fundamental human technology, one that transforms a group of individuals into a single, coordinated force. This brings us to the sixth and perhaps most intimate principle in our investigation, the human element itself. Our exploration of resonance began with the laws of physics and the properties of stone, but it must inevitably lead us back to the people who wielded that knowledge. What if the most sophisticated resonance generator was not a machine, but a chorus of human voices, a line of synchronized bodies moving as one? Historical records from across the world are filled with the echoes of this practice. Viking longships were propelled across icy seas by oarsmen who chanted to the beat of a drum, their unified strokes turning the vessel into a living, breathing entity. Enslaved African Americans forged spirituals and field hollers, using complex rhythms and harmonies to coordinate labor, preserve culture, and find a shared strength that transcended immense hardship. These are not mere cultural artifacts, they are documented examples of biomechanical efficiency. Science now confirms what these traditions have always known. When a group moves or chants in a shared rhythm, heart rates can synchronize, breathing patterns align, and a collective focus emerges that reduces perceived effort and increases endurance. The group becomes greater than the sum of its parts, operating on a single, resonant frequency. This is the power of collective vibration, a tangible energy generated by human intention and unity. Now we venture carefully into a more speculative yet profoundly intriguing layer. Throughout history, many cultures have held beliefs about the power of focused thought and intention, concepts sometimes grouped under terms like psychokinesis or distant mental influence. Modern parapsychology explores these ideas, though they remain deeply controversial and far from mainstream scientific acceptance. We are not making claims here, but we are asking a historical question framed by the resonance phenomenon. If a synchronized group can generate a measurable physical vibration through chant and rhythm, could that same collective focus have been directed in a more subtle way? Could the unified intention of hundreds of workers, amplified by the very sound waves they were producing, have interacted with the resonant state of the stone in a manner we do not yet fully understand? This is not about magic spells, but about the potential intersection of consciousness, biology, and physics. We know that our own bodies are resonant systems, our hearts beat, our brains emit waves, our cells vibrate. What happens when dozens or hundreds of these biological oscillators tune themselves to the same frequency, with the shared goal of moving a mountain? The reflective questions become deeply personal. Could this shared resonance have altered the builder's own perception, making the stone feel subjectively lighter, their own strength feel magnified by a powerful group psychology? Or, on a more physical level, could the specific frequencies of their chanting have directly coupled with the acoustic liquefaction of the ground or the internal state of the monolith itself, adding a human bio-acoustic layer to the mechanical process? This adds a rich human dimension to the technological mystery. It suggests the construction of these ancient wonders was not a silent, grim ordeal, but potentially a deeply communal and even ceremonial act. The site may have hummed not just with the sound of tuned stones or instruments, but with the living, breathing resonance of the people themselves, their voices and movements woven into the fabric of the work. This perspective does not diminish the physical principles of resonance, it completes them. It places humanity not as slaves to an impossible task, but as active, conscious participants in a dialogue with the material world. They were not just moving stone, they were singing to it, and in that ancient chorus they may have discovered a forgotten key to their own potential. The ground beneath our feet is not inert, it is alive with subtle currents. This leads us to a seventh and deeply interconnected principle, the ancient art of geomancy and the concept of the site itself as a resonant body. For the builders of these wonders, location was everything, but perhaps not for the reasons we first assume. Beyond practical concerns like water and quarry access, they seemed drawn to specific points on the landscape, places often described in later traditions as possessing special energy. This is the practice of geomancy, a word meaning earth divination, which modern researchers interpret as a sophisticated understanding of natural telluric currents, magnetic variations, and geological features. The theory suggests these master builders were not just constructing on the land, they were integrating with a living system. They may have sought out locations where the Earth's own vibrational pulse was strongest or most accessible, places where the bedrock itself hummed with a natural frequency. By carefully aligning their structures with these energies and with celestial pathways like the solstice sun, they could have been creating something far more complex than a simple building. They might have been crafting a resonant circuit, a closed loop of energy between the earth below and the cosmos above. The monument becomes the intermediary, the tuning fork that connects the two. We see this intention etched into the landscape across cultures. In Britain, the concept of ley lines, ancient straight tracks that connect mounds, stone circles, and holy sites, has long fascinated researchers. While their origins are debated, the alignment of so many sacred places along these linear pathways hints at a perceived network of terrestrial energy. In Ireland, the passage tomb of Newgrange, older than both Stonehenge and the Great Pyramids, is a masterclass in this alignment. Its narrow entrance passage is engineered so precisely that for just a few minutes at dawn on the winter solstice, a beam of sunlight travels the length of the corridor to illuminate the central chamber. This is not a happy accident. It is a deliberate marriage of architecture, astronomy, and the specific geography of the hill. Researcher Paul Devereux, who has studied Earth energies for decades, suggests that many ancient sites are located at points where geological faults or underground water flows create measurable micro-disturbances in the local magnetic field. He proposes that these places were perceived as thresholds, points where the veil between worlds was thin, and that the structures built there were designed to interact with this environmental signature. The practical implications of this are profound. If a massive stone pyramid or temple is built directly upon a key point in this energetic grid and is itself acoustically tuned, it could enter into a sustained harmonic relationship with the site. This coupling could act as a natural stabilizer, just as a tuning fork placed on a table will resonate more powerfully. A structure in energetic sympathy with its foundation might better distribute stresses, resist seismic activity, and maintain its celestial alignments over millennia. The Great Pyramid's near-perfect orientation to true north is not just symbolic, it is a geometric lock with the planet's rotational axis. The theory posits that this alignment, combined with its specific location on the Giza Plateau, integrates it into a planetary resonant system. It becomes less like a building and more like a permanent antenna, designed to receive, amplify, and perhaps even transmit specific vibrational information. This transforms our understanding of purpose. Were these monuments also designed as harmonic anchors for the land itself? The reflective question this raises is about consciousness. Did the ancients perceive the earth as a conscious, vibrating being, and see their sacred architecture as a way to communicate with it, to literally attune human endeavor to the song of the world? This perspective suggests the final secret of their accuracy was not just in the movement or shaping of stone, but in the sacred choice of where to sing. The walls of Sacsayhuamán do not simply stand against the mountain, they converse with it. High above the ancient Inca capital of Cusco, this fortress presents a stone puzzle that has defied erosion, conquest, and centuries of violent earthquakes. Its most famous walls are built from colossal limestone blocks, some weighing over 100 tons, fitted together in a complex, interlocking pattern with no mortar. The joints are so meticulously crafted that, as the saying goes, not even a blade of grass can find its way through the seam. This is not just skilled masonry, it is a form of geological lock and key, a three-dimensional tapestry of stone that has survived in a region notorious for tectonic upheaval. How was such precision achieved, and why does this specific, irregular pattern provide such legendary resilience? Local Quechua oral traditions offer a clue that resonates deeply with our investigation. They speak of a lost knowledge where certain plants, when applied to stone, would make it soft, almost like clay, allowing it to be shaped and fitted. Other legends mention stones that moved to the sound of songs or whistles. While modern minds might dismiss these as poetic metaphor, they align perfectly with the principles of resonant manipulation. What if the plant extract was not a chemical solvent, but a medium, perhaps a slurry that helped transmit specific vibrational frequencies into the stone? What if the songs held the precise tonal instructions? This case study allows us to apply our principles to a real-world, standing example. Imagine a multi-step resonant process employed by Inca master builders. The first step would be discovery. Before a single stone was cut, a skilled practitioner might have used a tuned instrument, like a hammer stone that rang at a specific pitch, to tap on different faces of a raw granite boulder. By listening carefully to the returning sound, they could map its internal structure and identify its dominant resonant frequency, the stone's unique sonic signature. This frequency becomes its key. The next step could be preparation. Using larger, perhaps chorus-based sound generators, they would direct sustained vibrations matching that key frequency at the stone. This resonant energy, focused along intended seam lines, could temporarily reduce the molecular friction within the granite, making it far easier to work. It would not melt the rock, but might allow master craftsmen to peck and polish it to its final, intricate shape with a level of control that seems superhuman with blunt tools alone. Now comes the true genius, the fitting. Each uniquely shaped block, having been tuned and prepared, is moved into place. The polygonal jigsaw pattern is not an artistic choice, it is functional acoustic engineering. When two stones with complementary resonant profiles are locked together, they do not just touch, they couple. They become a single, unified vibrational entity. During an earthquake, seismic energy travels through the ground as waves of destructive vibration. When these waves hit a conventional, rigid wall with straight mortar lines, the entire structure tries to move as one piece, leading to catastrophic cracks and collapse. But a polygonal wall like Sacsayhuamán's reacts differently. The energy of the quake enters the wall and is immediately channeled through a maze of interlocking joints. Each unique interface acts as a tiny shock absorber, dissipating the vibrational energy by allowing the stones to minutely shift and rub against one another without losing cohesion. The wall dances, it flexes, it redistributes the force harmlessly throughout its entire network before settling back into perfect alignment. It is a dynamic, vibration-dampening system carved in stone, a permanent testament to an understanding that harmony in structure creates resilience. This transforms our view of the site from a static archaeological wonder into a kind of frozen symphony, where every block is a note carefully placed to create a chord that withstands the test of time. The implications of this ancient insight ripple directly into our modern world, where engineers face the same eternal challenge, building structures that can endure the unpredictable fury of the earth. Granite hums with a hidden life. Within its speckled surface, a mineral called quartz is more than just decoration. It is a tiny, natural battery waiting to be awakened. This brings us to an eighth principle, one that ventures into the frontier of modern physics and ancient mystery, the idea of memory in stone. Quartz crystals possess a remarkable property known as piezoelectricity. When you apply mechanical pressure or stress to a piece of quartz, it generates a small, measurable electric charge. Conversely, when you apply an electric charge to quartz, it physically vibrates. This is not speculative science. It is the fundamental principle behind your wristwatch, your smartphone's microphone, and many modern medical imaging devices. Quartz is a transducer, a converter between mechanical vibration and electrical energy. Now consider the stones of the ancients. Granite, the favored material for so many megaliths, from the sarcophagus in the Great Pyramid to the walls of Sacsayhuamán, is rich in quartz crystals. These stones were not just shaped, they were subjected to what the resonance theory suggests were intense, sustained, and highly specific vibrational frequencies during their construction. This leads to a profound speculative question. If quartz converts vibration to electricity, and these stones were bathed in powerful resonant tones for extended periods, could that vibrational energy have left a permanent imprint within the crystalline lattice of the rock itself? Could the granite blocks be more than silent sentinels? Could they, in a sense, remember the song that formed them? This concept of structural memory in materials is not fantasy. Cutting-edge material science is actively exploring ways to store data in the atomic structures of crystals, creating memories that could last for millennia. The idea that intense, coherent energy can create lasting changes in a material structure is a solid physical principle. So, what might such an imprint feel like thousands of years later? This could offer a new lens through which to view the countless anecdotal reports from visitors and researchers at ancient sites. People often speak of a palpable feeling, a tingling sensation, or a profound sense of stillness when touching certain megaliths. Others report hearing faint, inexplicable hums or tones in specific chambers, sounds that equipment sometimes fails to detect. While these experiences are subjective and often dismissed as psychological, the piezoelectric principle suggests a possible physical mechanism. If the stone retains a subtle, patterned charge or a latent vibrational signature from its creation, perhaps certain individuals or certain atmospheric conditions could trigger a faint playback. It would be an echo not through the air but through the very substance of the stone, a ghost of the frequency that once made it malleable. This principle does not claim to prove anything, but it builds a bridge of plausibility. It suggests that the interaction between the builders and their material might have been a two-way street. They did not just impose form upon the stone, they may have engaged in a resonant dialogue with it, leaving an energetic signature woven into its crystalline heart. The monuments then become not just architectural achievements, but potentially vibrational libraries, their very substance encoded with the frequencies of their own birth. This transforms a walk among the ruins into something far more intimate. You are not just looking at history, you are in the presence of an object that may still hold, within its atomic structure, the faintest memory of the chorus that raised it. It invites a quiet question: what other memories might our world be holding in stone, waiting for us to learn how to listen? Every compelling idea must face its toughest critics. The resonance theory, for all its elegance, is met with firm skepticism from mainstream archaeology, and these counter-arguments deserve our serious attention. The most common critique is a simple one: the absence of evidence. No sonic tools, no ancient tuning forks or giant singing bowls have ever been unearthed at these sites. If such a sophisticated technology existed, skeptics argue, where is the physical machinery? They point to the well-documented discovery of stone pounders, copper chisels, and wooden sledges as the complete and sufficient toolkit. This perspective champions Occam's razor, the principle that the simplest explanation, the one requiring the fewest assumptions, is usually correct. In this view, the simplest explanation is immense, coordinated human labor over generations, not a lost science of sound. Respected archaeologists often characterize alternative theories as fringe speculation, arguing they undermine the ingenuity and sheer effort of ancient cultures by searching for shortcuts that did not exist. They note that what looks like impossible precision can sometimes be the result of natural settling, or the skilled use of simple measuring rods, plumb bobs, and a lifetime of artisan knowledge passed from master to apprentice. Another point raised is survivorship bias. We see only the magnificent successes, the projects that were completed with stunning accuracy. We do not see the countless failed attempts, the cracked obelisks and collapsed walls that did not survive the centuries, which would testify to the immense trial and error involved. These are strong, logical points from a discipline built on tangible evidence. To ignore them would be unscientific. But a truly robust investigation must also examine the gaps within these conventional explanations. The argument from absence that we have found no sonic tools is powerful but not conclusive. What if the primary tool was not a complex device, but a perishable technique? We do not find the music of a culture, only the instruments that survive. If the technology relied on specific chants, rhythms, or the use of water as a resonant medium, these would leave no direct fossil record. Their evidence is not in the artifacts left behind, but in the anomalous properties of the artifacts that were created. The call for the simplest explanation is also worth probing. Is the image of tens of thousands of workers hauling ropes for decades, using tools that seem materially inadequate for the task, truly the simpler scenario? Or does it simply replace a technological mystery with a logistical one of similar scale? Interdisciplinary thinking asks us to cross boundaries. A stonemason explains how to shape stone. An engineer calculates the forces needed to move it, but a physicist might ask if there is a way to change the properties of the stone itself. The resonance theory does not seek to replace human labor, but to propose a method that could have organized and amplified that labor to a degree that makes the end results plausible. It suggests that the master's knowledge may have included an understanding of vibrational states, a practical physics woven into ritual and craft. This dialogue between skepticism and speculation is not a weakness, it is the engine of discovery. The mystery of ancient construction accuracy remains open not because one side has all the answers, but because both sides have compelling questions that the other cannot fully resolve. This tension is what makes the investigation vital. It invites us to look at the same old stones with new eyes and to listen for echoes of a science we are only beginning to remember. The Tacoma Narrows Bridge sang itself to pieces. In 1940, this elegant suspension bridge in Washington state earned the nickname Galloping Gertie for its dramatic, rolling oscillations in the wind. One November morning, a steady breeze set the bridge deck vibrating at its exact natural frequency. The phenomenon of resonance took over, amplifying the gentle undulations into violent, twisting convulsions. Within hours, the structure tore itself apart and plunged into the water below. It was a devastating and unforgettable lesson in the raw power of vibrational physics. Engineers had designed for strength, but not for this invisible, rhythmic force. The bridge collapse became a foundational case study, teaching generations that to build on a grand scale, you must respect the song of the structure. This modern catastrophe proves the principle beyond any doubt. Resonance is a tangible, formidable force in our world. But this same force, once understood and harnessed, becomes a tool of astonishing precision. Today, we wield resonance not as a mystery, but as a technology. In factories around the world, ultrasonic machining uses high-frequency vibrations to cut, drill, and shape materials like glass, ceramics, and hardened steel with microscopic accuracy. The vibrating tool tip, oscillating tens of thousands of times per second, causes the material at the point of contact to fragment cleanly, allowing for intricate designs impossible with conventional force. Look upward at a modern skyscraper in a seismic zone, and you will find resonance at work as a guardian. Engineers install massive tuned mass dampers, often huge concrete blocks or pendulums weighing hundreds of tons in the upper floors. When an earthquake or high winds set the building swaying at a dangerous frequency, this counterweight moves in the opposite direction, absorbing and dissipating the vibrational energy to keep the structure stable and safe. It is a dance of equilibrium, using one resonant mass to quiet another. In advanced laboratories, researchers even experiment with acoustic levitation, using precisely arranged sound waves to create pressure nodes that can suspend small droplets or particles in mid-air, allowing them to be manipulated without any physical contact. This is not science fiction, it is applied physics. We are, in our own technological language, learning to sing to matter. The reflective question this modern mastery forces upon us is profound. If our species, with all our digital sensors and computational power, is still uncovering and applying the deep principles of resonance in the 21st century, is it not conceivable that another culture, over millennia of direct observation and dedicated craft, could have discovered a macro-scale application of the same immutable laws? This thought does not diminish our modern achievements, it reframes the ancient ones. It suggests that the path to technological insight is not a single, straight line. Our civilization chose the path of electronics, metallurgy, and combustion. Another might have taken a deeper dive into the science of vibration, honing an empirical, hands-on knowledge of how frequency interacts with stone, water, and the human body. Their tools were different, their language for describing the phenomena was poetic and symbolic, but the physical laws they were exploring were the same ones that felled a bridge and now steady our towers. This parallel legitimizes the entire inquiry. It moves the resonance theory from the realm of pure speculation into a space of historical and scientific plausibility. We are not asking if the ancients had our technology, we are wondering if they cultivated their own, born from a different relationship with the natural world. Their laboratory was the quarry, their sensor was the trained ear, and their legacy is written in stones that have withstood the test of time. Scattered across the globe, separated by vast oceans and millennia, the same architectural fingerprint appears. The seamless, polygonal stonework of Sacsayhuamán in Peru could be a distant cousin to the Cyclopean walls of Mycenae in Greece. The precision-fitted basalt blocks at Nan Madol in the Pacific echo the interlocking granite of the Osirian in Egypt. Japan's enigmatic Yonaguni monument, with its sharp, right-angled terraces submerged off the coast, shares a family resemblance with the leveled bedrock foundations of the Giza Plateau. These are not identical structures, but they speak a common architectural language, one of mass, precision, and a profound disregard for what we consider the technological limits of their respective eras. This pattern ignites the ninth and most expansive principle in our investigation, the possibility of a lost global science of vibration. The question is not necessarily about a single, unified Atlantis-style civilization that circled the globe. A more nuanced and perhaps more compelling idea is that of a shared archaic discovery. Different cultures at different times may have independently stumbled upon the same fundamental truths about resonance, about the vibrational nature of matter and how to harness it. This concept is sometimes called a paleoscience, a primordial understanding of natural law that predates our current scientific framework. Think of it like the discovery of fire. We do not believe that fire was invented in one place and then taught to every other human group. Multiple societies, through observation and experimentation, learned to create and control flame because the principle was always there, waiting in the natural world. What if the manipulation of stone through sound was another such universal discovery, a paleotechnological insight into the fabric of reality itself? Proponents of cultural diffusion, like researcher Graham Hancock, look at these similarities and see the fingerprints of a lost, advanced maritime culture that seeded this knowledge during the last ice age, a mother civilization whose legacy was carried forward by the survivors. Mainstream archaeology, favoring isolationist theories, argues that these are brilliant but independent inventions, human ingenuity solving similar problems with similar, albeit simple, tools. The resonance theory offers a potential bridge between these viewpoints. It suggests that the common thread may not be a shared teacher, but a shared teacher in the form of nature. If the laws of physics are universal, then the key to moving mountains finding the resonant frequency of stone is also universal. A curious and observant culture in the Andes, experimenting with sound in their granite quarries, could have made the same breakthrough as a culture along the Nile working with limestone. The principles of sympathetic vibration or acoustic liquefaction do not change with longitude. They are always true. This transforms the global pattern from a mystery of contact into a potential mystery of convergent discovery. Different cultures listening to the same song of the earth may have learned to sing along in their own unique ways. Their applications and architectural styles differed, shaped by local materials, beliefs, and needs, but the underlying vibrational science could have been the same. The evidence is not in traded artifacts or shared glyphs, but in the shared outcome, the megalithic footprint. This perspective does not require ancient transoceanic voyages, though it does not rule them out. It simply posits that humanity's early journey with technology may have had a significant branch we have forgotten, a branch dedicated not to levers and pulleys, but to harmonics and frequency. Over time, as cultures rose and fell, as knowledge was guarded by priestly castes and then lost to conquest or catastrophe, this paleoscience fragmented. The deep principles faded into legend, into stories of magical papyri and singing stones. The practical techniques devolved into ritual, the precise frequencies preserved only as sacred chants whose original purpose was forgotten. What remained were the indestructible monuments themselves, the final proof of a method we can no longer fully replicate. They stand as silent, stubborn questions carved in stone, asking us if our current path of technological progress is the only one humanity has ever walked, or if we are, in a very real sense, rediscovering a science that once allowed our ancestors to converse with the bones of the world. The profound stillness inside the king's chamber is not merely an absence of sound. For many who stand within that colossal granite space, a palpable shift occurs, a deep sense of awe that borders on the visceral. This reported experience points toward a final, deeply human principle, the potential intersection of resonant architecture and human consciousness itself. If these ancient sites were indeed precision-tuned instruments, their purpose may have extended far beyond construction. They might have been designed as environments for transformation, crafted to interact directly with the mind and body of the visitor. This 10th principle moves from the physics of stone to the inner experience of the person, exploring the idea that the builders were not just engineers, but masters of psychoacoustics. Modern research offers intriguing clues. Studies into the effects of sound on the human system show that specific frequencies can influence brainwave patterns, heart rate, and emotional states. For instance, certain low-frequency sounds, like those produced by large drums or deep chants, can encourage theta brainwaves, states associated with deep meditation, creativity, and restorative calm. Other frequencies, like the much-discussed 432 Hz or the historical solfeggio tones, are often cited in alternative research for their purported harmonizing effects, though mainstream science continues to investigate these claims. The key insight is not about a single magical frequency, but about the principle of entrainment, where a powerful, consistent external rhythm can gently guide our internal biological rhythms to synchronize with it. Now apply this to a space like the king's chamber. Acoustic analysis suggests its dimensions cause it to resonate at a fundamental frequency close to 114 Hz, a low hum at the threshold of hearing. If rituals or chants within that chamber excited this natural resonance, the entire stone room would become filled with that pervasive vibration. A visitor would not just hear the sound with their ears, they would feel it in their chest, in their bones. In such an environment, the effect could be profound. The constant, low vibrational input could quiet mental chatter, alter the sense of time, and induce a state of receptive tranquility. This transforms our understanding of Gothic cathedrals as well, with their vast, reverberant spaces designed for chant and pipe organ. The sustained notes of sacred music, echoing for seconds in the stone vault, would create a similar immersive sonic bath, potentially elevating a sense of connection and transcendence. The reflective question becomes deeply personal. Were these places designed as technological aids for spiritual or mental practice? If resonance could soften granite, could it also soften the rigid boundaries of ordinary awareness? This reframes the ancient builders' goal. They may have been constructing tools for inner exploration as much as outer monuments. The precision was not just for astronomical alignment or structural permanence. It was to calibrate an instrument that played upon the human nervous system. The architecture becomes a deliberate interface between the vibrational field of the Earth and the vibrational field of human consciousness. In this light, the reported feelings of peace or awe are not mysterious or magical, but potentially a predictable response to a carefully engineered environment. The builders, through empirical observation over generations, may have learned that certain proportions and materials created certain internal experiences. They tuned their temples like one would tune a violin, not for the note it produces in the air, but for the state it produces in the person standing within it. This suggests their greatest achievement was a holistic science, one that saw no separation between the sacred and the scientific, between shaping stone and shaping the human experience. They worked with a unified understanding that everything from a block of granite to a beating heart operates on principles of vibration, and that harmony in one realm could create harmony in another. Theories demand proof, and proof requires experimentation. When faced with the mystery of ancient construction, a bold few have decided to stop debating and start testing, using modern tools to explore an ancient possibility. This is the realm of experimental archaeology, where the resonance hypothesis meets the hard reality of the laboratory. The results are a fascinating mix of tantalizing hints and sobering limitations, a story not of definitive answers, but of a persistent, valid scientific question. Our journey into modern testing begins with that enigmatic figure, Edward Leedskalnin. Working in secret at his coral castle in Florida, he single-handedly moved and positioned massive blocks of oolite limestone. While he never revealed his exact methods, leaving behind only cryptic notes about magnetic currents and the secrets of the pyramids, his achievement stands as a challenge. It proves that a single individual without modern machinery could accomplish what conventional wisdom says should require heavy equipment. Leedskalnin's work is not a controlled experiment we can replicate, but it is a powerful anecdote that insists alternative methods must exist. It serves as the inspiration, the real-world puzzle that prompts more rigorous investigation. Moving into more documented territory, researchers have taken the principles of resonance into the lab. One notable series of experiments involved using powerful subwoofers and amplifiers to direct specific low-frequency sound waves at small samples of granite and other hard stones. The goal was to see if sustained vibration could induce stress fractures, alter the surface, or reduce the effort needed to work the material. In some tests, observers noted that the stone samples seemed to exhibit unusual behavior under certain frequencies, with fine surface dust mobilizing in distinct patterns, almost like a liquid. In other cases, the intense sound waves appeared to create microscopic fissures along crystalline boundaries. These effects are subtle, a far cry from softening a monolith, but they are measurable. They demonstrate that sound energy can interact with stone in non-trivial ways, influencing its surface properties and potentially weakening its internal structure at a microscopic level. The most precise modern analog comes from ultrasonic machining, a technology we use today. Here, high-frequency vibrations, far above the range of human hearing, are applied to a cutting tool. This causes the tool tip to oscillate tens of thousands of times per second, and when brought into contact with a brittle material like granite or glass, it pulverizes the material at the point of contact with remarkable precision. This process works not through brute force but through transmitting vibrational energy. While this uses a physical tool bit rather than sound waves alone, the core principle is resonant energy transfer. For ancient application, the speculative leap is whether they could have achieved a macro-scale version, using large, tuned instruments to induce a similar state throughout an entire block, making it more amenable to shaping with simpler tools. Yet, for all these intriguing leads, full replication remains stubbornly out of reach. No experiment has yet made a sizable granite block levitate, become plastic, or cleanly split along a chosen seam using only sound. The energy requirements to achieve such dramatic effects on a large scale are immense, and focusing that energy without modern materials and electronics is a monumental challenge in itself. The experiments that show interesting effects often do so on small samples in highly controlled environments, a far cry from a windswept quarry. This honest appraisal is crucial. It separates serious inquiry from fantasy. The resonance theory, as it stands, is a compelling framework with physical plausibility, but not yet a proven reconstruction of ancient methods. This mixed record, however, is not a failure. It is the very process of science. These experiments generate valuable data about how materials respond to vibrational stress. They force us to refine our questions. Perhaps the ancients used sound not as a standalone magic wand, but as one component in a sophisticated process, combined with precise thermal cycling, chemical agents from plants, or expertly managed mechanical pressure. The experiments keep the question rigorously alive, proving that investigating the acoustic properties of stone and the potential for sonic manipulation is a valid, challenging, and worthwhile scientific pursuit. They transform the mystery from a fringe speculation into a legitimate frontier of interdisciplinary research, where archaeologists, acousticians, and materials scientists can meet. The stones may still hold their secret, but now we are learning how to listen with more than just our ears. The solstice sunrise at Newgrange is not a spectacle for the living alone. For 17 minutes on the shortest day of the year, a slender beam of light penetrates the darkness of a 5,000-year-old tomb, traveling down a 60-foot passage to illuminate a chamber deep within the earth. This event is too precise, too perfectly engineered to be a mere symbolic gesture. It speaks of an intent that merges the earthly with the celestial in a profound and deliberate dance. This alignment is our 11th principle, the idea that ancient monuments were not just pointed at the stars, but actively tuned to them, seeking a form of cosmic resonance. The builders perceived the heavens not as a silent, distant clock, but as a source of vibrational energy, a symphony of cycles whose rhythms could be harnessed here on Earth. We now understand that the cosmos is far from silent. Space itself hums with vibrations we are only beginning to measure. Planets and stars generate immense infrasound, frequencies far below human hearing, pulsing through the solar system. The sun emits a constant stream of electromagnetic energy and charged particles, the solar wind, which interacts with Earth's own magnetic field, creating phenomena like the auroras and subtle, global electromagnetic pulses. These are not mystical forces, but measurable physical energies, the universe's own low-frequency broadcast. The revolutionary proposal is this: what if the ancient architects, through meticulous, long-term observation, learned to predict these cosmic rhythms and designed their structures to act as receivers? By aligning a passage tomb like Newgrange to the winter solstice sunrise, they were doing more than marking a calendar date. They were timing the structure's interaction with a specific moment in Earth's annual vibrational relationship with the sun. The first light of the solstice may have been the trigger, the key that unlocked a resonant state within the specially shaped chamber for that sacred window of time. This concept transforms stone circles, pyramids, and temples from passive observatories into active instruments. Think of a radio telescope, its parabolic dish carefully angled to collect faint signals from a specific point in the sky. The massive, geometric forms of ancient architecture may have functioned on a similar principle, but for a different spectrum of energy. The Great Pyramid's facets, aligned to true north and the cardinal directions with minute precision, could have been designed to interact with Earth's geomagnetic field or the subtle infrasonic hum of the planet's rotation. The placement of Stonehenge, with its sight lines to both the summer solstice sunrise and the winter solstice sunset, might have been about capturing the interplay of solar energies at the extremes of the yearly cycle. The structure itself, built with specific types of stone that may have had unique conductive or resonant properties, becomes the hardware for this cosmic software. The in-depth analysis suggests a breathtaking purpose. These alignments allowed the monuments to synchronize or charge with cosmic frequencies. During these aligned windows, the architecture might have entered a heightened state of resonance. For a site like Newgrange, the solstice light could have been the catalyst that activated a prepared space. The chamber, empty and dark for most of the year, is suddenly flooded with radiant energy. This sudden influx of photons striking surfaces calibrated by geometry could have excited the quartz within the granite, generating minute piezoelectric currents. The entire space might have temporarily hummed with a different quality of energy, a confluence of light, vibration, and intention. This was not about generating power for machines, but perhaps for experience. It could have been a designed environment for ceremony, meditation, or what the builders perceived as communication with ancestral or cosmic realms, using the amplified resonance of the site as a bridge. This principle elegantly connects the entire investigation. It links the microscale of using resonance to shape a single stone to the macroscale of aligning a mountain of stone with a star. Both actions spring from the same foundational worldview, that vibration is the fundamental connective tissue of reality. The frequency that softens granite and the frequency of a planetary orbit were seen as part of a continuous spectrum. By building structures that resonated with the local Earth and then timing their use to cosmic cycles, the ancients may have believed they were plugging their sacred sites into the greatest power source imaginable, the universe itself. Their calendar was not just for planting crops, it was a schedule for accessing different vibrational ports in the cosmic network. This perspective does not diminish their spiritual beliefs, it grounds them in a sophisticated interpretation of natural law. They were not worshipping the sun as a god in a simple sense, they were honoring it as the most visible conductor of a cosmic orchestra, and they built instruments to play along. Among the polished statues and broken pottery in museum cases, quieter mysteries wait. Scattered across the ancient world are artifacts that defy easy classification, objects whose forms seem to whisper of a different kind of knowledge. These are not the grand monuments, but the small, puzzling tools, the things held in a hand. They are often dismissed as ritual objects or mere decoration, but when viewed through the lens of a potential sonic science, they invite a second, more curious look. Take the so-called Baghdad battery, a clay jar found in Iraq dating to the Parthian period, roughly 2,000 years ago. Inside was a copper cylinder and an iron rod sealed with asphalt. When filled with an acidic liquid like vinegar, it generates a small electric charge. Mainstream archaeology suggests it may have been used for electroplating jewelry or for some form of medical therapy. Yet its very existence proves that the principle of generating electricity through chemical means was known in antiquity. For our exploration, it raises a provocative question: could such a device, or a larger version of it, have been used to create the precise, sustained electrical pulses needed to excite a piezoelectric material like quartz in stone? It is not proof, but it is a piece of the puzzle, demonstrating that ancient minds were experimenting with fundamental energies. Then there are the famous reliefs in the Hathor Temple at Dendera, Egypt. They depict large, bulb-shaped objects held aloft on pillars, with what appear to be cables or snakes trailing into a box, and figures standing nearby. The conventional interpretation describes them as symbolic depictions of a lotus flower birthing a snake, representing cosmic creation. However, some engineers and alternative researchers see a striking resemblance to modern Crookes tubes or early light bulbs, suggesting they might represent a form of ancient electrical or plasma technology. Again, we are not declaring this as fact, but observing the pattern of inquiry. If these carvings are symbolic, they are deeply unusual symbols. If they are technical diagrams rendered in the only symbolic language available, they become something else entirely, a potential glimpse into an applied science that utilized radiant energy. The importance lies not in forcing one interpretation, but in acknowledging the strangeness and asking what practical knowledge might be encoded in sacred art. Perhaps more directly relevant are the curious stone objects from various pre-Columbian sites in the Americas. Researchers have uncovered carefully carved stones in shapes that bear an uncanny resemblance to modern acoustic lenses or parabolic reflectors. Some are smooth, dish-like forms, while others are elongated with finely tuned ridges. In a conventional framework, they are labeled as ceremonial altars, seats, or grain grinders. But their precise geometry and the effort required to shape them from hard stone gives one pause. What if their purpose was acoustic? A parabolic stone dish could focus sound waves, much like a satellite dish focuses radio waves. It could be used to direct a specific frequency toward a stone block with great intensity, or to listen for the faint, resonant return from a distant monolith. Another enigmatic find includes stones shaped like modern tuning forks, with two prongs of specific lengths that would vibrate at a set pitch when struck. These could have been the master tuners, the reference instruments used to calibrate larger sound generators or choruses. Without written manuals, we can only speculate, but the forms themselves are suggestive. They look like tools designed to interact with waves, not to crush grain. The reflective challenge these artifacts present is profound. If we uncovered a truly advanced ancient tool, one based on a physics we have overlooked, would we even recognize it? Our museums are filled with objects categorized by function, based on what we know, based on our own technological lineage. A stone dish becomes a grinding slab because we know grinding. A carved cylinder becomes a ceremonial mace head because we know ceremony. But what if their function belonged to a different branch of knowledge altogether, one that saw sound as a tangible, malleable force? We might be looking at the equivalent of finding a smartphone in a medieval dig site and calling it a polished black mirror or a strangely shaped slate. We would describe its physical attributes correctly, but completely miss its purpose. This is the intellectual humility these artifacts demand. They ask us to set aside our assumptions, not to embrace wild speculation, but to allow for the possibility that ancient innovation may have followed paths we have since paved over. The next time you walk through a museum, pause before a case of simple stone objects. Look past the label, consider the shape, the symmetry, the material. Could that smooth, lens-like curve be designed to channel a frequency? Could those precise grooves be meant to guide a vibration? The stones of the monuments shout their mystery, but these smaller artifacts whisper it, inviting us to listen more closely to the quiet clues left behind. Orpheus did not just play music, he moved mountains with it. In the ancient Greek myth, this legendary musician's lyre was so powerful its melodies could charm wild beasts, make trees uproot themselves to follow him, and cause stones to rearrange themselves into walls and cities. For centuries, this was read as pure poetic metaphor, a beautiful illustration of music's emotional power. But what if we are reading it only half correctly? What if, beneath the layer of allegory, stories like this preserve instructions? This brings us to a 12th and transformative principle, the role of myth and symbol as a protected technical manual. When a civilization faces the threat of collapse, of lost languages and scattered peoples, how does it preserve its most precious knowledge? It weaves that knowledge into stories, into symbols, and into rituals that are performed generation after generation. The information becomes encrypted, safe from those who would misuse it or simply fail to understand its power. Comparative mythologists like Joseph Campbell and Mircea Eliade have long noted the striking similarities in foundational stories across cultures separated by continents and oceans. These parallels, they argue, point to shared human archetypes and psychological patterns. Yet another layer exists. Could some of these shared motifs also point to a shared, forgotten understanding of natural law? The Vedic texts of ancient India, for instance, speak in detail of vimanas, flying craft said to be powered by the rhythmic chanting of specific mantras and the knowledge of the winds. Modern interpretations often leap to literal spacecraft, but a resonance-based reading offers a different decryption key. The mantras are precise sound formulas. The winds could refer to controlled vibrations or frequencies. The description of propulsion through sound aligns not with jet engines, but with the principles of acoustic levitation and resonant energy transfer that our own science is now exploring in laboratories. The myth becomes less about literal machines and more about the physics of using organized vibration to overcome gravity and inertia. To decode a myth, we shift our focus from asking, "Did this happen exactly as written?" to asking, "What physical process might this symbolize?" Look for the action described. A hero blows a horn and a wall falls. A deity chants a syllable and a mountain is split. A musician plays a note and stones become soft. Now correlate that action with a physical principle. The horn's blast matching the resonant frequency of the wall. The syllable's vibration finding a fault line in the rock. The note from the lyre inducing a temporary state of plasticity in the granite. The story's fantastical elements, the giants and gods, become the narrative vehicle, the memorable characters that carry the technical data safely through time. The core truth is not in the characters but in the described effect of sound upon matter. This perspective transforms sacred texts and folklore from quaint collections of superstition or simple moral tales into potential libraries of a paleoscience. The knowledge was not lost because it was written in stone. It was lost because we stopped understanding the language in which it was written. We mistook the encryption for the message itself. Rituals served a similar function. The precise movements of a ceremonial dance, the specific sequence of tones in a temple chant, the geometric patterns drawn in sand during a rite, these could all be methods of preserving complex information through performance. The initiate learns by doing, embedding the pattern, the rhythm, the frequency into muscle memory and community tradition, long after the original why has faded into the sacred mystery. This does not strip these traditions of their spiritual depth. It potentially adds a layer of profound purpose. It suggests the spiritual and the scientific were once a unified pursuit to understand and harmonize with the vibrational nature of creation. The myth of Orpheus, then, is not just a story about the power of art. It is a cultural memory encrypted in allegory of a time when humanity understood that every stone has a song, and if you could learn to sing it, the world itself would become your instrument. A powerful technology does not simply vanish without a trace. To understand the silence that followed the age of megaliths, we must ask not only how such knowledge was used, but why it was ultimately forgotten. The disappearance of a sophisticated science of resonance is as critical to the mystery as its apparent existence, adding a layer of tragic depth to the ancient stones. Consider the fate of Greek fire, that legendary incendiary weapon of the Byzantine Empire. Its exact formula was so fiercely guarded by the imperial court that when Constantinople finally fell, the secret died with its last keepers. The knowledge was not inherently lost to physics. It was lost to political collapse and deliberate secrecy. Similarly, the exact recipe for the supremely durable Roman concrete, which still endures in seawater after 2 millennia, was forgotten for centuries after the empire's fragmentation. These are historical examples of how specialized, elite knowledge can vanish when the social structures that nurture it disintegrate. The practitioners of a resonant science would have been the ultimate elite, a priestly or artisan caste who held the keys to moving mountains. Their understanding was likely not written in books but encoded in ritual, passed from master to apprentice through years of careful initiation. This knowledge was power, literal and profound, and such power is always guarded. When the great centralized civilizations that supported these castes fell, whether through invasion, environmental change, or internal upheaval, the living chain of transmission was broken. The apprentices died before they could become masters, and the songs that shaped stone faded into legend. A deeper shift may have also turned society away from this path. Early philosophies and spiritual systems often saw the material world as alive, imbued with spirit and vibration, a perspective perfectly suited to a science of resonance. But later paradigms began to draw a sharper line between the spiritual and the physical. Some religious movements emphasized faith and divine transcendence over material manipulation. Philosophical schools began to prize logic and abstract reason over the hands-on, experiential knowledge of the artisan. When the world is seen as inert matter to be conquered or transcended, rather than a living partner to be harmonized with, the incentive to learn its vibrational song diminishes. The technology of resonance, rooted in a worldview of sacred interconnection, would have seemed less relevant, even heretical, to new ways of thinking. It became not just forgotten, but purposefully abandoned as humanity's focus shifted. We must also consider the possibility of a more abrupt reset. While the evidence is complex and debated, the geological record shows that our planet has experienced profound climatic shifts and catastrophic events throughout human prehistory. A major global cataclysm, whether a rapid climate change, a series of massive volcanic eruptions, or the impact of a comet fragment, could have devastated the fragile networks of civilization that existed 12,000 years ago or more. Such an event would not only destroy cities and disperse populations, but it would shatter the continuity of culture. The survivors, struggling for basic survival in a shattered world, would have little capacity to preserve an advanced, nuanced science. The practical knowledge of farming, shelter, and simple tool-making would take precedence. The high art of singing to stone would become a half-remembered dream, a story of a golden age when giants built with the bones of the earth. This idea, often called a cultural bottleneck, suggests that our technological journey may not be a straight line upward, but a path with deep valleys of forgetting. The loss, then, is not merely of a construction technique. It represents the fragmentation of a holistic world, where science, art, spirituality, and community were woven from the same vibrational thread. Our ancestors may have possessed a profound unity of understanding, where shaping a temple was the same act as tuning a hymn and aligning with a star, all expressions of a single resonant reality. Its disappearance created the chasm we now stare across, separating our modern, analytical marvels from their ancient, experiential genius. The stones stand as monuments not only to what they achieved, but to a conversation with nature that we are only now, with our satellites and sensors, beginning to tentatively restart. This forgotten harmony between humanity and the humming world is perhaps the most poignant echo left behind. The human body itself is a quiet symphony of vibration. Our hearts beat in a steady rhythm, our brains emit delicate electrical waves, and even our cells oscillate at frequencies too subtle to perceive. This is the foundation of our 13th principle, the idea of bioresonance, which suggests that living systems can be influenced by the vibrational fields around them. If ancient builders understood how to shape stone with sound, could they also have understood how shaped stone could, in turn, shape us? This leads us to the long-standing tradition of lithotherapy, the use of stones for healing, a practice found in cultures from every corner of the globe. Specific stones like jade, quartz, or lapis lazuli were not merely decorative. They were placed in tombs to accompany leaders on their journey, worn as amulets for protection, and set into the very walls of temples. Modern science is cautious, yet research into the piezoelectric properties of quartz, which we discussed earlier, offers a plausible physical mechanism. A stone under constant, subtle stress from its own weight and the Earth's vibrations could generate minute electromagnetic fields. If that stone was also precisely cut to resonate at a specific frequency, it might emit a steady, subtle vibrational signature into its environment. Now expand that idea to the scale of a megalithic chamber. Imagine a space like the King's Chamber, constructed entirely from massive granite blocks rich in quartz, each one potentially tuned and positioned not just for architectural stability, but for acoustic harmony. The chamber itself becomes a giant resonator, designed to amplify and sustain a particular frequency. The speculative leap of the healing stones hypothesis is that these frequencies were not random. Through generations of observation, the master architects may have identified tones and vibrations that promoted calm, focused awareness, or a sense of physical well-being. They could have designed these spaces to function as vibrational sanctuaries. A person entering such a chamber would be immersed in this engineered field. The pervasive, low-frequency hum, felt more than heard, could encourage the brain's electrical activity to synchronize, potentially easing mental agitation and inducing a profound state of restorative peace. This is not about claiming miraculous cures, but about considering the intentional design of environmental medicine. Many ancient cultures viewed illness as a form of dissonance, a being out of tune with nature or the cosmos. Their sacred sites, then, might have been designed as tuning devices. By spending time in a space resonating at a harmonizing frequency, an individual might, in their understanding, be brought back into alignment. This principle completes the holistic picture of resonance as a lost technology. It was not a tool for one purpose, but a unified science that wove together the fabric of reality. The same understanding that allowed them to find the song in a granite block to move it, also informed them how to arrange those blocks to sing a song that could soothe the human spirit. They saw no division between building a temple and fostering health, between aligning with a star and aligning a person's inner state. It was all a matter of achieving harmony across scales, from the cosmic down to the cellular. While this idea resides firmly in the realm of alternative history and is far from mainstream acceptance, its value is in the profound question it leaves with us. If our ancestors did possess such an integrated science, what does its absence mean for our own fragmented world, where architecture, medicine, and spirituality so rarely speak the same language? The stones, in their enduring silence, may have been designed to teach us not just how to build, but how to be. The scattered clues now converge into a single, breathtaking possibility. Let us weave the 12 threads of resonance into a single tapestry, a speculative but internally consistent model of how a megalithic masterpiece might have been born. This is not a claim of historical fact, but a thought experiment, a demonstration of how these principles could have functioned as an integrated, lost science of construction. Imagine a process that begins not with a hammer but with a hum. First, the masters would seek not just any location but the right one. Guided by the ancient art of geomancy, they would search for a site where the Earth's own energies were most accessible, a place where telluric currents or unique geological formations created a natural vibrational node. This would be their foundation, the living bedrock to which their structure would be tuned. Using aligned stones or observation platforms, they would map the celestial pathways, ensuring the final monument would lock into specific solar or stellar events. The site itself was the first component of the instrument. At the quarry, the work began with listening. Before any cut was made, a practitioner might use a tuned hammerstone to tap the living bedrock, listening intently to the returning ring. Each variation in pitch revealed the hidden internal structure, the natural fault lines and resonant signature of the granite. Once a suitable block was identified, the real work commenced. Larger sound generators, perhaps massive singing bowls, tuned stone slabs struck in unison, or a coordinated human chorus, would direct sustained vibrations matching that stone's key frequency. This resonant energy, focused along the intended seam, would travel through the stone, temporarily reducing internal friction and making the granite more amenable to separation. The block was not blasted free, but gently persuaded to release from the earth, its own song guiding its birth. Shaping the raw monolith required another layer of sonic artistry. Here, the principles of cymatics and sympathetic vibration would come into play. The desired final shape, perhaps encoded in sacred geometric patterns, served as a vibrational blueprint. By applying specific frequencies to the stone, they could induce a state where the material became more malleable. The cymatic pattern of that frequency acted as an invisible guide, a template of pressure nodes that helped master craftsmen peck and polish the block toward its perfect form with astonishing control. The intricate, non-repeating patterns of polygonal masonry may not be artistic whims, but the natural result of stones shaped while humming in a resonant state, each one uniquely conforming to the energetic field that softened it. Transporting these giants presents the most iconic puzzle, and here water and rhythm combine into a powerful solution. A prepared causeway from the quarry to the temple site would be saturated with water. The same sustained frequencies used in the quarry, perhaps generated by a line of large drums or tuned pillars, would then be applied to this sodden path. The combination of sound and water could induce a state of acoustic liquefaction in the soil, turning the earth into a temporary, near-frictionless slurry. Upon this resonant slipway, the massive block, itself still vibrating from its shaping, could be moved with coordinated human effort. The workforce, unified by rhythmic chants and synchronized pulls, would become a single biological oscillator, their collective intention and physical effort amplified by the resonant ground beneath them. The stone would seem to glide, a mountain made fluid by a forgotten harmony. Finally, placement was the act of permanent tuning. Each uniquely shaped block was not simply stacked, but carefully fitted into a growing polygonal puzzle. As each stone settled against its neighbor, their complementary resonant profiles would couple, locking together not just physically but acoustically. The entire wall or chamber would become a unified vibrational entity. The final structure, now complete, would sit upon its chosen energetic site, aligned to celestial cycles. It would be a closed circuit, a resonator tuned to the low hum of the earth below and the cyclical pulses from the cosmos above. The monument was now active, a permanent instrument designed to interact with the vibrational fabric of reality itself, whether for ceremonial focus, communal gathering, or purposes we can only dimly perceive. This model, from the listening at the quarry to the silent hum of the finished temple, demonstrates a profound internal logic. It shows how the principles of resonance could flow seamlessly from one stage to the next, creating a holistic science where architecture was the physical manifestation of applied vibrational knowledge. While we may never find the blueprint or the master's tuning fork, the stones themselves stand as the final, enduring note of that ancient song, inviting us to consider a past where humanity did not conquer nature with brute force, but conversed with it through the universal language of vibration. The silent stones may soon begin to whisper their secrets directly to us. Our tools for listening have evolved far beyond the human ear, entering a new frontier where technology acts as a bridge across millennia. This is no longer just a debate of theories, but a tangible, hopeful search for answers, driven by instruments that can peer through solid rock and algorithms that can hear patterns invisible to the human eye. The first breakthrough comes from seeing the unseen. Ground-penetrating radar sweeps across desert sands and ancient floors, sending pulses of energy into the earth and painting a picture of what lies beneath. It has already revealed hidden voids and anomalous structures near the Great Pyramid and within the bedrock of Stonehenge, hinting at networks we have never walked. Even more profound is muon tomography, a technique that uses cosmic rays from space. As these subatomic particles rain down, they pass more easily through empty spaces than through dense stone. By placing sensitive detectors around a monument, scientists can create a three-dimensional X-ray-like image of its interior density. This is how researchers confirmed a large void deep within the Great Pyramid, a discovery that proves we still do not know everything about these ancient wonders. These non-invasive scans are the first true step in a new kind of archaeology, one that respects the integrity of the site while mapping its hidden anatomy. The data they produce is vast and complex, a digital echo of the past. This is where a second technological revolution meets the first. Artificial intelligence, with its ability to find subtle correlations in immense datasets, is becoming an invaluable partner. Imagine feeding the precise dimensions, materials, and alignments of 1,000 ancient sites into a learning algorithm. It could search for hidden acoustic patterns, identifying which chamber shapes consistently amplify specific frequencies, or which stone types are consistently used in structures that have survived major earthquakes. Beyond physics, AI could analyze symbolic art and inscriptions across cultures, not for linguistic translation, but for geometric and pattern recognition. Could it detect a recurring waveform hidden in a decorative frieze, or a mathematical ratio in a temple layout that corresponds to a known resonant frequency? This is not about replacing historians, but giving them a powerful new lens. The most definitive answers, however, may come not from scanning or analysis, but from recreation. Advanced materials science laboratories now possess the equipment to subject samples of granite, basalt, and limestone to incredibly precise and powerful vibrational stresses. The experiments of the past used simple speakers. The experiments of the future can use focused ultrasonic arrays, electromagnetic resonant drivers, and laser interferometers to measure microscopic changes in the stone's structure in real time. The goal is clear: to definitively test whether sustained, specific frequencies can reduce the hardness, alter the fracture mechanics, or lower the coefficient of friction of these ancient building materials. Can we make granite behave, even temporarily, in a way that would allow it to be shaped or moved with the tools we know they had? A single, repeatable, peer-reviewed demonstration of this effect would transform the entire conversation. This technological convergence calls for a new kind of explorer. The mystery of ancient accuracy demands an open-minded, interdisciplinary team where an archaeologist's knowledge of context sits beside a physicist's understanding of wave mechanics, an acoustic engineer's skill in modeling vibrations, and a materials scientist's ability to test them. It requires a dialogue free from rigid dogma, where data is the primary language. The romantic notion of a lone genius deciphering everything is fading, replaced by the powerful reality of global collaboration. This means the story is not ending, it is entering its most exciting chapter. You are witnessing this shift in real time. Every new scan, every AI analysis, every laboratory experiment adds another piece to a puzzle that has remained incomplete for centuries. The resonance phenomenon is no longer just a compelling idea from the past, it is a testable hypothesis for the future. The call is not for belief, but for curiosity and rigorous, shared investigation. The stones have kept their secrets for thousands of years, but for the first time we are building the tools that might finally let them speak. From a single, impossible block of stone, we have journeyed across a hidden landscape of frequency and vibration. We have traced 12 interlocking principles, from the resonant song of a tuning fork to the cosmic alignment of a temple, weaving a startlingly coherent picture of a lost science. This exploration of the resonance phenomenon does not offer a final, dust-covered answer, but a compelling key, one that fits the lock of ancient construction with an elegance that brute force explanations lack. It suggests our ancestors were not merely primitive laborers moving mountains through sheer numbers, but sophisticated technologists of the subtle energies that permeate our world, masters of a dialogue with matter itself. They listened to the hum of the earth and learned to sing along, turning vibration into a tool, a language, and perhaps even a form of medicine. While a single, definitive artifact may still lie buried, the pursuit of this idea is itself a transformative act. It enriches our understanding by blending the rigor of modern physics with the profound awe of an ancient mystery, reminding us that history is not a closed book but a living conversation. So the next time you stand before an ancient monument or even see a picture of one, try a different kind of observation. Look past the silent mass, try to listen. Not with your ears alone, but with your imagination. Feel the scale, consider the precision, and ask what forgotten harmony might still echo within those stones. If this journey into the hidden science of the past has resonated with you, we invite you to share your own thoughts and questions in the comments below. Subscribe to continue exploring history's greatest enigmas with us, and keep questioning the stories written not in ink but in stone.